So thank you so much for joining the webinar. This is a third edition of the DevOps webinar that we have planned. First, we have started with the DevOps introduction and followed by Docker in production. And this is the third webinar on microservices. So if in case you have missed the first two sessions, so we will share you the link pertaining to the first two webinars that we have organized in the past, and you can go through it.
Yes.
So here are some of the housekeeping instructions before we start. All phones are set to mute. If you have any questions, please type in the chat window located beside the presentation panel. So we will ensure that all the questions will be answered towards the end of the session. So we'll continue to collect more and more questions and answer towards the end of the session. So thanks and enjoy the session. And so let me give a quick brief about Newt Global before we start. Newt Global is a DevOps company. We are the leader in DevOps transformation, test automation, and cloud enablement, are a few of our primary service offerings. So we currently primarily work with Fortune 50 companies at present, and we have experience implementing end-to-end DevOps toolchain for these customers. We have global delivery capability, having a couple of offices in US and a couple of delivery centers based out of India. So we have platinum level partnership with leading product companies, and we extensively, as part of our COE, we build frameworks and use it for our customers. Mainly to reduce time to market. So here is our speaker today, Venkat Tirunalai, DevOps practice leader at Newt Global. So Venkat has around 16 plus years of experience in IT industry, and predominantly was working in the area of DevOps and cloud. At Newt Global, he is the DevOps practice leader, and he also heads the pre-sales function at Newt Global. So over to you, Venkat.
Yeah, thanks a lot for your introduction, Satish, and hello everybody. And also present with me is one of Newt Global's key architect, Himanshu Chauhan, who will also be present, and he will also share some of his views with the audience, especially towards the end of the webinar. Okay. So basically, Newt Global, as my colleague Satish introduced, basically it's the DevOps company, and typically the way we see DevOps, we see it as three levels of maturity. We have the onboarding zone, we have the engineering zone, and then we have the re-architecture zone. Typically involves rewriting applications or developing applications as microservices, and that's going to be our topic for the day today. So what exactly let's talk about the villain in the whole game, and then let's get on to the microservices part. So what exactly are monolithic applications, right? So it's a traditional way of development where all modules are implemented at one place. You got the DB access, you got the messaging, the web components, and then the key challenges that you face there are you're weighed down by the weight. Initially, you start off in a very good manner. It's really kind of very fast, and but eventually, as the size of the monolith grows, the problems associated with the monoliths starts coming up. If you make a small change, the impact is huge. The testing time taken is huge. The time to build and deploy and then troubleshoot in production is also huge. So it's kind of it adds on a lot of delays to your entire cycle, and and also, like for example, in a monolith, a language has to be standardized. Suddenly, if for a particular function you need a different language, it's not possible to introduce a new technology on demand, and that makes a kind of innovation and growth really slow, especially as the monolith gets really large. So what exactly are microservices, right? So so basically in a monolithic environment, right, as we said, individual services cannot be scaled on demand, right? So like for example, if you have an e-commerce application and you know that search and display products are the most used services, right? Very rarely people kind of go to the checkout cart, and but you end up scaling the entire application those many number of times as you want the search, and there's a lot of resources that are wasted. Also, it's slow to scale all the services at one shot. So these are a couple of things that impact the performance in addition to your development lifecycle problems that I cited earlier. Okay, and in a microservices environment, basically individual services can be scaled on demand. Suppose suddenly you say, hey, I got a search service and that needs to be like really massively scaled. Yeah, I can do that independent of the checkout cart, so that I don't invest in unnecessary resources. And because I'm scaling a point service, it's really efficient and much more scalable and much more faster design as compared to that of a monolith. Right? So why do we need microservices, right? So typically, as I mentioned earlier, it gives you like loosely coupled processes and kind of the advantage that it can be scaled independently. Also, you can deploy to the production independently, and if particular functions require specific tools, like for example, if you want to implement machine learning and you believe that R is or Python is a better language, you can develop you can use that technology, and then you can have Java probably for the rest of the services, right? That kind of makes you a much more advance on new technologies much more rapidly, right? So each microservice, as I said, is a mini application that has its own architecture, its own business logic, and many times, though not necessarily always, it will have its own database schema, right? So a lot of people think that, hey, it's a great practice that every microservice has its own data store. Yeah, it sounds, it's very theoretical in nature. While many services do warrant this kind of a design, there is also a good case where a couple of services can actually share a database, right? Just to reduce your operational complexity. End of the day, it all boils down to how you can serve your end customer, monolith or microservice. How can you serve your end customer, and with the minimal possible overheads. Right. Now, when you talk about scalability, as I typically you can scale individual services separately to a larger extent, and that gives a lot of scalable nature to your microservices design. And as I said, the high level benefits, basically you're enforcing a level of modularity. Individual service developers are free to choose whatever technology, though this freedom comes at a price of complexity, but they are free to choose whatever technology that makes sense for their particular domain. And each microservice, as I said, is being independently deployed, right? So and each microservice is small, so impact of testing is kind of contained with that microservice itself, right? And then the ability to identify the root cause and then fix the issue and roll back and retest and redeploy is a lot lesser than a traditional application. So these are a couple of benefits that you can see. Right. Now, taking microservices to the first steps, right? So I think when you're developing application from scratch or rewriting an application, right? So a couple of things. While I mentioned that it's easy to choose whatever technology for, you can have a different technology for each service. However, you need to understand that having 10 technologies in one large project can actually be a burden on you when you try to scale your team, especially if you're doing something across geographies and so on, right? So it pays to standardize, but at the same time, if there is really a case for a new technology, like for example, there are some teams which might prefer Scala and Spark for the machine learning algorithms, yeah, some of the services, whereas rest of the thing can continue to be in Java, let's say example, that might be a good decision. But having .NET for one microservice, Python, and then Node.js, that really is not really the criterion that you need to use, especially if you're targeting production. You need to also be very clear on your concurrency model. Should you be using actor model consistently throughout? That makes sense. Even if the teams are like independent, it makes sense to use a standard concurrency model. And third is like we do a lot of temporal decoupling, and I can talk about it more in some of the pattern, anti-pattern, and solution section, which I'll be covering later. So temporal decoupling is basically, kind of, as an example, you don't call us, you don't pass on data to another service directly through a REST call or something, but instead you write to a queue and let that, that other service pull data back from the queue, so that, if there are unwanted spikes, the load can be smoothened on the service, so that it's able to serve a larger deal of customers, right? And you are not having any unplanned downtime and so on. Okay. Going from a monolith to a microservices, right? There are a lot of considerations that you need to have. Like, in most often than not, you have to refactoring a monolith, and converting that to a microservice is just theoretical. It's in general, legacy, especially if your application is a legacy application, it has evolved over a span of say 8 to 10 years, and you are planning to refactor. That's usually a very bad idea, unless your application is less than 1,000 lines of code, right? Most of these legacy applications tend to be at least 500,000 to anywhere 1 million plus lines of code, and over a period of say 8 to 10 years, there are a lot of frameworks, etc., that have changed. A lot of APIs that have been added. There are a lot of code which is redundant, right? And then that will be very difficult for you to refactor. So rewrite is generally a very good solution for developing microservices. Now, typically, what you need to do is you need to understand your system boundaries. What are the new services that you're planning to write? You need to do a lot of work around defining events, business events that help you create, business domains. Because at the end of the day, microservices follow what is called a domain-driven design. Okay. So typically, we will do something like a context mapping, and then you'll have relationships between the various services. For example, we have this web user profiling, and that having a conformist relationship, with the personal financial management banking, kind of use case. So we need to kind of visualize your entire application in terms of the various verbs and nouns, and what relations they are having with various other verbs and nouns, so that we are able to create a proper domain-driven design. Right. So it's also important, like you need to have some kind of patterns that are pretty common. Like, for example, this is a mobile app, and then there is an IVR. So you can actually, let us say you're booking a cab, or you can either do it through an IVR application, or you can do it via a mobile application. And here, as you can see, it's writing to a queue. So there is a pipe which is where all your requests will probably go, and then then there is a backend microservice, and then there's another service which in turn which talks to the original backend service. So that's the typical kind of design that you would have. Now, let us say, for argument, like there is some problem in the pipe, like the number of requests sitting in the queue have really exceeded the length of the queue, and there is some problem, and that goes down, right? And that actually kind of causes, because every service is now trying to hit this pipe, and then and then the pipe is not available, right? So everywhere there is fire, and the whole application goes down, right? So typically we introduce basically a circuit breaker, and the circuit breaker design pattern at all these services. So it kind of tells you if a particular service is down, it lets the other services also know that the service is down, so that there is no cascading failure. Every hundreds and thousands of services trying to contact the failed services and clogging the system, and causing a lot of kind of a lot of services to go down. So those type of errors can be kind of resolved. Okay. Like other aspect that we need to talk about is like the orchestration of services in production. Like let us say that there is a sample e-commerce application, and there's a general scenario, right? Let us say at any point in time 1,000 users are there in the entire system. So 995 would actually do window shopping, which means they will look at the search, they look at the product, and they look at the catalog, right? These three services are probably search and product services, right? These are the ones that 995 users will be kind of targeting. 5 would actually add something to the cart, and 3 would actually end up buying something, right? So as you can see from this, performance load characteristics, it will tell you volumes that about how you need to kind of, scale your entire microservice application. So probably you need to look at scaling only a search and product to serve this kind of workload, right? And typically this would be achieved because using your container orchestrator, each service would have its own load balancer, based on which you'll be able to kind of identify what's the workload, and based on your configurations you can scale out these services, right? So again, the orchestration mechanism that you are using, and then there are several orchestration mechanisms you can use. Basically, suppose in case you're using a platform as a service like Cloud Foundry, you can use the built-in orchestration mechanism there. Or Cloud Foundry also, say example, has support for Kubernetes. Or if you're using, you can also use Docker Swarm, which is what I'm going to talk about. That doesn't necessarily mean I'm recommending Swarm over other services. It's just an illustration that I have in this presentation. Okay. So basically, we use Docker in production with Swarm. Basically, you get quick deployment, good resource management, good backup management. You get system security. Docker Swarm has got basically the overlay networks implementation where you can mask your ports, especially when you are scaling across systems. Especially when you're scaling across systems, and you also need to implement container monitoring and image and storage management. Okay. So typically you have a swarm that is monitoring, let us say, a couple of your clusters, and so there is actually a node failure. So swarm is or swarm can actually kind of replicate these depending on the availability of compute and the various hosts and their health. It can actually help you migrate the containers and their state to different kind of hosts. And swarm, however, if you notice, swarm is also susceptible to a single, the host at which is hosting the swarm manager, that node itself can fail, and that's basically a wrong pattern to have. So a typical pattern is basically to have the swarm manager and 2 backups. So in the event of a failure, basically what would happen is both these backups would compete to become the new manager. It would take the state of the old manager, and the one that competes in the race would actually become the new swarm manager with all the data available of all the hosts, and would actually take over in managing the host. So this way we will not have any kind of single point of failure into your entire orchestration mechanism. Okay. At this point, I would like to discuss some patterns and some anti-patterns in the entire microservices ecosystem. So a lot of people ask, like, how do I kind of start off in a microservices environment. So do I need to start, like, while it's great in a puristic world to start with a microservices architecture, but then understand one thing: microservices architectures also come with a lot of overheads, a lot of operational overheads that you need to keep in mind, and that's why it's best to start off with a monolithic application. Okay. Microservices basically are so in which case you will have the because of the monolithic application, it's very small. It's actually kind of a microservice to you, but without the operational overhead. So you'll be able to kind of be very agile. So when your monolith is like beginning to break out, and now you are aware of the advantages, disadvantages of microservices, the problems of monolith. The moment you start noticing that, hey, there's a potential problem that can come up, that's when you start isolating your services into microservices. So give an illustration. Let us say that I have an app which is having several chunks of code as a monolith. Let us say an exception handling, a code block 2, code block 3, and code block 4, right? Suddenly you want to, like, the exception handling, you want to scale for all the, because every app, whatever goes wrong, you have a common exception module, and that suddenly becomes overloaded or something. So you decided to scale. The problem is for that one exception module, you're scaling the entire application because it's a monolith. You don't have a choice, right? That's when you start noticing, hey, why not a microservice? So it makes a lot of sense to separate out the exception as a microservice, and you kind of start scaling that independently, so that your scaling is much more simpler. You actually see the you and your management actually see the benefits of microservice. Again, what I'm showing you right now is basically a practical standpoint as to how we start. Many times, if you already have a built-in ecosystem for microservices and you're confident of managing the operational overhead, there's nothing stopping you from rewriting the application from scratch, starting itself as a microservice. So it's really a choice, but I prefer, like, the nice safe route of starting as a monolith and then splitting into microservices as required, and then with a very conscious mind that eventually I will get the benefits of microservices in a very controlled manner. So that's my approach towards kind of development. Right. So database schemas. So basically, right. This is another gotcha for kind of in the entire microservices development, especially so what typically happens is, like, okay, I got an exception block. I have a version 1 that talks to the database. I have a code block that logs the exception, and that logs the data back into the database module. Right now, the problem with this is, tomorrow I basically change the some signatures that I want to write, and then I have a version 2 in the schemas. Right, what would happen is one of the two interactions will kind of fail. So typically the code block in this case would fail because the schema has now been kind of updated, and then there is an issue out here, right? However, if basically how do I solve this problem, right? So typically we use a pattern where we have a gatekeeper, and then we have an exception service. So we have the exception logging mechanisms, and then the interactions. We can ensure that even if I have a version 2, the interactions between the code and the exception service is taken care of, and then the exception and the exception service is taken care of. So these two versions could actually coexist, and then we write, and then at our leisure we can actually make sure that this is also upgraded to version 2. Okay. However, this kind of creates some kind of lockstep deployments scenario. What would happen here is basically you need to kind of ensure that, like, let us say for argument I have made the exception service as version 2, and what would happen in this scenario is, both these being version 1, the interactions between the the various code blocks and the exception, that would be a break in the outcome out here, right? So we need to make sure that the entire services kind of are orchestrated in the lockstep fashion, so that we are able to kind of have a smooth roll into the production, basically, right? So typically, we use something known as semantic versioning. So what we do is, in a semantic versioning, a thumb rule is very simple. If it's a release that doesn't have kind of a backward compatible change, we just change the number after the decimal, so it becomes 1.2 or 1.3. If it does have a backward incompatible change, in which case we bump up the version release, and that's how the operation teams knows that we need to kind of migrate the entire log stop out here, so the entire set, all the services, so that we get a proper version in the production, basically, right? And then in the case of the decimal increments, we would basically kind of upgrade this without any impact to the services, and then at our leisure kind of upgrade the other two versions as well, right? Now if I want to do a backward incompatible change, so if you notice, I bought in a service that is version 2, but note I have not swapped the two services. I bought in the service, now I have also upgraded both V2, then only I have made the connection with the V2 of the exception service, and then I have kind of delinked the 1.2 service. So that's a safe way of kind of taking that particular production change in a lockstep fashion with proper semantic versioning. It avoids a lot of confusion. You can work very closely with the operations team to kind of make these kind of deployments happen. Couple of other things. We can use queues to smoothen your workload, right? So suddenly like let us say that one of your services is having such spikes, and that's putting a lot of kind of load on your system and your performance of your service. What you typically do is when you instead of making a service call to another service, you write to a queue, so that now and then we can have an asynchronous reader that would read off the data from the queue and start probably sequentially or start writing to the database or talking to the other services. So this way you can smoothen out the impact. The peak will fall down almost like 50 to 60% as you are seeing in this scenario, and you're able to kind of manage the workload. Now what can happen is like things can go really out of control when you're not you're totally underestimated the length of the queue. So you're writing to the queue, but then and your reader is the workload spikes in such a way that it supersedes your capacity for application to handle the load. It supersedes the length of the queue. Then yes, you can certainly run into some problems, but then that's really an abnormal situation. And then once that happens, next time around you can plan either for a better more number of scaled services, or probably a larger queue, or combination of both, so that you can handle the workload in a better manner, right? So typically this is how, like there's an app, and there's a UI that the load is coming in, and probably the all the requests are now being written to the queue. There is probably a sequential worker that takes data, reads the queue in a sequential manner, and then kind of processes and writes it to a particular database. Okay. So in this pattern, basically, as I mentioned, I can log the exception to the queue, not wait for the entire process to get over, go on to the next request, right? So this helps me with with the same amount of resources, I can serve my incoming workload in a much better manner, right? All right. Now another basically kind of pattern that we have seen in while working with many of the applications, we see basically there are a lot of hard-coded IPs and ports, right? It's better that we use basically a service registry like a console or a Netflix Eureka. And of course, there are many other service registry products. Like there are even routers some people use, and there are some differences between a router and generally the software-based services. So generally, it's more for almost 80 to 90% of the use cases. It's always better to use software-based service such as the Netflix Eureka or the Council as a service discovery. So they give a good mechanism by which each service would actually kind of make a call to the service registry, figure out the the address of the other microservice to call, and then therein make that call to that service, so that each service knows the address of the service, and there's a proper communication. And also you don't really have to maintain hard-coded IP addresses. That kind of causes a lot of mess in your code and will cause a lot of confusion when you're trying to debug your application, right? And also hard-coded IP addresses, especially if you're in a cloud, it's kind of very risky thing to do, right? So debugging, basically, yes, you can use the best way. A good suggestion is like use a lot of correlation IDs, which you can grab from the UI, and say, hey, this particular session or this particular request has this unique ID, and then log them all over. So eventually you can know that this and all the issues that are out here is pertaining to this particular request, and I'll be able to debug, make some sense of the logs, and also understand what went wrong in the application. Okay. So it's a kind of practice that would kind of help you in your production debug. Right. So and as I mentioned, right, you got to maintain queues. Each microservice many times has its own database, right? And and then there are these queues, and then there are these various services which need to be scaled independently. There are orchestration, container orchestration mechanisms, right? And then there are Docker containers. So there are a lot of moving parts when it comes to a microservices environment. Also, many times in microservices, things can go out of hand, because earlier the number of service or the number of APIs that were there were only on the periphery of the monolith. But here, because of microservices, there are a lot of API interactions. So there's a lot of and then there are a lot of design changes that need to happen over a monolith to write microservices, because you're using temporal decoupling, you're using queues. So the design and architecture gets really complex. The operations, and then again, a lot of people will now use at least 2 to 3 different technologies or languages to develop the microservices to suit the purpose, right? So all these things add to the complexity and of the whole mode of operations, right? And makes the life of the operations team very miserable. So it's really a best practice to use a platform as a service. Typically, the most popular ones are called Cloud Foundry and OpenShift, but you can also consider IBM Bluemix. And for most of you who have not heard about the Days platform, Days is something which has been acquired by Microsoft, which is a very interesting development, given the fact that it's basically built on top of Kubernetes, and it's on Docker. So it's and then Kubernetes being a Google product, so this is a very interesting development. It happened somewhere around the first week of May 2017, and these are the 4 platforms as a service that you need to watch out for. I cannot emphasize in any better that if you are really writing a microservices application, do not deploy it on a raw infrastructure service platform like OpenStack or AWS. The right platform would be one of these, or there are many more platform as a service. Probably I'm not aware or I'm not worked on. So, but you can pick up the right platform as a service, as it will really remove the operational complexity from the entire development and process, and it will be really a great value addition to your microservices stack. Okay. Just to summarize this presentation, basically we started off, like we told them, like, we started off with what are microservices, what are the best practices, how do you scale, what are the orchestration, right? But my advice, start for most use cases, it will be very beneficial if you start as a monolithic application. You look for the now that your microservice is aware, you look for reasons as to why microservices, what is the benefit that you're going to get, and start pulling out the services from your code, right? That's the one smart approach that I would like to suggest. Couple of things, gotchas in the entire microservices development. Pay attention to the schemas. Try to get a semantic numbering system into the whole thing, right? And that will help you manage and coordinate with your operations teams. Other thing is, you need to decouple your services with queues. We use Apache Kafka a lot to kind of create a proper publish subscriber model, but then yeah, you can use RabbitMQ or whatever queuing tool that you have in that you prefer as a decision. But it's important that you use that. We need to use discovery products like Eureka or Council, and software-based discovery products are generally preferred. We need to implement circuit breakers, so that it's important, because this microservices, the way I see them, because of the number of RESTful interfaces, it's a lot of REST calls happening. There will be some services which receive calls from every other microservices, and because they are independently deployable, developers tend to treat it as different applications. So you may be surprised that one application gets called by at least 30 to 40 microservices. So what would happen, and what would happen here is basically if one service goes down and every service is now making multiple attempts at retrying to connect, right? So it's like 100 microservices if they're connecting the service, and each of them is doing 3 to 4 attempts to reconnect just to make sure they're able to get onto the service. So you're talking about 300 hits on the service which doesn't exist, right? So it's kind of a very cumbersome scenario, and it can result in a lot of cascading failures in production. So it's important you implement circuit breakers, and then implement some alternative scripts, or to up the service at some other location, so that you're able to serve the other services, right? Now, as I mentioned, you can use correlation ID as a tip with a lot of graphs and logging to make debugging really simpler, because things can get really complicated in microservices environment, and finding out where your error is, it goes a long way into kind of explaining that, right? And the biggest tip I would say is use a platform as a service, to something like Cloud Foundry or an OpenShift. The reason being, all these tools, once you adopt a standard way of development, that is a 12-factor app or something, you can basically, it gives you a certain operational functions out of the box. For example, in Cloud Foundry, you have these Diego cells, so you don't need to worry about dockerizing and or containerizing your application. You can just do a CF push, and the entire containerization and orchestration part is taken care of, right? So a lot of your work, the operational overhead, is picked up by the platform as a service. Okay. So this is in a nutshell the entire best practices as to how to take microservices into the production. Okay.
Thanks a lot, Venkat. I think we are with this, we are end of the session, and we can probably take some of the questions that you have. We already received some of the questions, and we try to cover as many questions as possible.
Right. So one question is basically, what is the difference between microservice and monolithic application? Yeah, so thanks, Andy, for asking this question. So to answer this question, I'll go back to my original slide. So basically, what the regular application, right? So when you develop an application, let us say your application has got lot of features like billing. Let us say you're billing a travel application, right? You have got a driver management application, a function, you got a trip management class, you got a billing. So you create a giant war file, you create several classes and you package the whole thing as one war file, right? So which means you have one giant application having all these features as classes and methods that you have implemented. So this is called a monolithic application because end of the day the artifact is only one, which basically which basically encompasses all the services. So this is called monolithic application. And what is basically microservices? So basically, what is a microservice application, right? Microservice application is something the same features, right? If I take passenger management, build it as a separate service, then I build billing as a separate service, notification, payment, driver, trip, right? If I build them as separate service, not just separating them as services, but also like I make the design in such a way and add some more logic so that these services are independently deployable. They are loosely coupled to rest of the services, right? These are the note. No, just taking an application, monolithic application, chopping it into multiple pieces doesn't give you microservices. You will have to model the application from a domain-driven design perspective, from an a relationships perspective, and you have to create each component as an independent service, which is loosely coupled or totally independent from the other services. So that is the design element that you need to bring. So it's not as straightforward as taking this passenger, putting it in a container, and then you call it a microservice. It may work for many, but not all the cases. Okay. So an application which is developed in this manner is called microservice environment. Now, how microservice is different from service-based architecture or SOA? So it's a very good question. So a lot of people basically talk about microservices as SOA 2.0, but I would say it's really an evolved version of SOA. A lot of SOAs have got enterprise service buses that encapsulate a lot of functionality, whereas microservices are really kind of where the we only look at a central point for service discovery. Every other functionality is encapsulated in the service. An important part of the microservice is that each service is independent, it's loosely coupled, and it is highly functional. Okay, that's the important discussion. Now, question is like please provide some sample, right? So for a microservices sample, basically what I would say is like take an e-commerce application, right? Now what I would do is I would have search as a separate microservice, catalog is a separate microservice, create customer profile, new profile is microservice, update profile is a separate microservice, right? Now if I have to do the same thing in an SOA architecture, right, I would have probably an enterprise service bus, I would have a lot of common functionalities programmed behind the ESB, and then only the bare minimal things pulled out from the service, and services are will be highly interlinked in the case of SOA. So clearly it's a design that differentiates between SOA and a microservice. Right. Now from your experience, the biggest failure based on what was the biggest failure based on microservice? What did you learn? How did you recover? So the biggest failure on microservice basically was like you have a service, and if that fails, and then there are hundreds of services, like for example I could have a authentication service. Now if that particular node is down, every other service will keep on pinging that service till and then it will be a very big mess, because let us say you have 200 services, microservices, every one of them is going to ping their authentication service for something or tokenization or something. What will happen is, and if that service node is down, it will cause a cascading set of failures, right? So the earlier we implemented microservices without the circuit breakers. That is where we really failed. and we realized it the hard way that we need a proper circuit breaker mechanism to kind of make sure that you know, the microservices are operational. Now, we did not ignore circuit breakers just for fun. We ignored it because we thought it was operational overhead and it will slow down the whole system. But in a microservice environment, it's absolutely necessary to have a circuit breaker for most designs. Now, other question is how to track get status of request at live when that being in process. Okay, I'm not able to follow the question. How to track get status of a request at live when that is being in when that is being processed by one of the microservice, right? So one thing is basically you can resort to do logging, where you are able to kind of you know, look at the logs and you know which are being published, and then you know, have a view of what's happening in the services and what's the status of the, you know, what is the life cycle of that particular service. So that is something which you can certainly do. Second, there are monitoring tools that are available, you know, like you know, Dynatrace or you know, some of these tools which will monitor these services in production and also kind of help you understand you know, where your time is being spent and other things, so that you will be able to kind of debug, right? With share nothing concept of service, how do we preserve data integrity across my that's a very good question. So we do, and if you recollect, we talked about temporal you know, decoupling, right? So I'll give you a simple example that makes it easy. Now, if you remember, we talked about an e-commerce system. So let me go back to the slide that will make it easy to yes. So in an e-commerce system, let us say that you have one more functionality called customer profile. Now, what happens in a, let us say each of these microservices have their own databases, right? So when I'm creating a customer profile, I am entering data like shipping address. Now, customer profile is a separate microservice. It has its own database, and for argument, let us say I'm using Cassandra, right? For just for fun. I mean, just for the illustration, basically. And now, let us say that I have Oracle DB for the payment card, because for payments, I want a very robust DB, time-tested DB, which will, you know, doesn't matter if it's slow, but it should be very accurate. So I don't want anything open source. So as a technology decision, I take Oracle, right? So I have a payment microservice, which is, you know, kind of talking to Oracle. I'm also having a one-click, and this payment module is a one-click module. Now, there is data inconsistency problem when customer chooses to change his address, because customer will go to the customer profile. I mean, the UI will talk to the profile microservice, and customer will customer doesn't care if it's a microservice or a monolith at the back end. He will just enter the data in the UI, and his shipping address has changed. Now, how will a Cassandra DB sync back to an Oracle DB, right? That's a big problem. And then correctly that you have said, with share nothing concept of microservice, how do we preserve data integrity across multiple microservices which has its own data store? So what we typically do here, Muthu, is we use an event-driven architecture or temporal decoupling, as I mentioned. So we create a publish-subscribe model, right? So because the customer profile microservice is the creator of the data called shipment address, right? So that becomes the publisher. And because the one-click pay or payment microservice is basically the consumer of that or is a secondary or consumes that service, it becomes a subscriber to that data, right? So what would happen is, moment I make any change on that data, it would get published to the Kafka queue and will get put in the queue, and the subscriber would actually pull out the data and would actually update itself. So that is the design pattern. It's called event-driven design architecture, design pattern for microservices. That is the kind of pattern that you need to use to kind of share the data across services. I hope I've answered your question. By the way, it's a very good question. Okay. Himanshu, would you like to add something more on top of this?
No, I think Venkat, you have covered that thing. So that's one of the decisions you have to take when you are segregating your database, that how you will maintain the sanity of all the databases that has been used by different microservices. And that's one of the particular reasons that people are still going with a monolithic database design with microservices at this point.
Right. So yeah, to add, thanks very much, Himanshu. So to add a little bit to what Himanshu is also talking is, right, as if you recollect in the earlier slide I mentioned, while it's theoretical that every service has to have its own data store, it's not what practically people implement. So people implement a combination of services with its own data store and some microservices which share the databases. So that way you can optimize the data integrity and the performance issues with the database. Okay. Yeah. So I think there's another question: how to manage the authorization between modules, right? So you can use OAuth as an authorization with token keys between two services, right? You can also, if you are familiar with the Spring Cloud, you can also use the the secrets module to kind of manage your tokens, and where you're able to communicate between two services. And Himanshu, would you like to comment on how two microservices can communicate in a secure manner with authorization?
I think the best option, as you already said, is OAuth. So so OAuth option, which you can generate a token and carry forward that token while during the whole communication between two microservices. Another approach which we have figured out in one of our application is that we only uses a communication between microservice via UI application. And UI application, we already have a SSO authentication. So we don't have any communication between microservice or anything outside that boundary layer. So that's why you can you have a single point of entry point.
Right. And also for third-party microservices, you can use API keys, which is generally the industry accepted norm for tokenizing across third-party services. How do you build, manage microservices for third-party external services? That's a very good question, and in fact, couple of things from a security perspective. API keys are one of the tokens that you need to use and to kind of authenticate for these services. Second, and the most ignored part in the security aspect of the third-party microservices are the two things here. One is good API design, because if you're a third-party microservice and you need to have basically Swagger-based documentation exposed for the external parties so that they understand how to use, and it has to be really well documented, because otherwise your microservice, your third-party services will not sell. Second, you need to have very powerful API design, or you need to really have idempotent REST API implementations, so that you are able to give meaningful APIs to your to your end customers, and and pretty much basically your microservices, whatever patterns that we discussed, right, from an internal development would remain more or less the same when you design the third-party microservices. Okay.
Great. So I think with this we reached the end of session. We have a few more questions to be answered, but we would prefer to send you them over an email in the interest of time. So if you have, in the meantime, if you have any questions, feel free to write to us. We will share you the presentation as well as the webinar video link, maybe maximum in 24 hours of time. So you can go through that. Along with that, we also share the previous two webinars links. You can very well go through it. You can go to our YouTube channel and you do like it and comment if you have any questions. So please expect an email from us, and thank you so much for joining this session. Have a great day.
Yeah, thanks everybody.
Thank you.